Hello everyone. Today I would like to show you how to solve the inverse Laplace transform. Okay, before this, you know how to solve the Laplace transform using by definition or by using by table or using by properties. So now we need to inverse the Laplace transform. What do you mean here is, okay, previously this is the symbol for the Laplace transform, and now we use the inverse. We change from the S domain, we change the S domain to T domain. If Laplace transform, we change the time domain to S domain. Okay, so this is the difference between Laplace transform and inverse Laplace transform. Now let's look at the example. Inverse Laplace transform of the 8 over S. Okay, so how to solve this? We know that from the table of Laplace transform, you obtain A equal to A over S. So now, inverse Laplace transform of 8 over S actually is, you can take out the constant 8, and then you inverse Laplace transform of 1 over S. Now you can see the pattern. Okay, so you know that this is equivalent to 8. This is because when you are from here, A equal to, okay, this is the FD and this is the Fs. So if your Fs is A over S, your Ft is A. If now your Fs is 1 over S, so your Ft is 1. So similarly, the inverse transform of 1 over S is 1. So you obtain 8. Okay. Now we look at the second example. Inverse Laplace transform of 8 over S power of 3. Okay, we know that the t power of, we know that the t power of n equal to n factorial over S power of n plus 1. Okay, if you look at here is S power of 3. So for sure it is S power of 3, and the n it should be 2. So we take it out. 2 and S power of 3. And if 2 is means that is 2 times 1. So from here we know that the answer for the, if we factorize it out, means that there is a 4. 4 times 2 is equal to 8. So this answer will be 4 t power of 2. Okay, another example, inverse Laplace transform of 2 over S plus 3. From the table of transform, Laplace transform, we obtain exponent at equal to 1 over S minus A. So this one is Fs, this one is Ft. Okay, so if you compare with S plus 3 here, if you compare with S plus 3 here, means that the A is negative 3, right? If you have 1 over S plus 3, this means that the A is equal to negative 3. So we can write in this way. So inverse Laplace transform of the 2 over S plus 3 is equivalent to, we can take out the 2 just to make the format same to the this one. So S is minus 3. So the format is the same. Okay. And we know that we have the 2 and then the exponent 80. A from here is negative 3. So 2 exponent negative 3t. Okay, another example. Inverse Laplace transform of 2 over s 3s minus 7. Okay, if you look at here, you have 3s minus 7. Usually, we only have one s. We don't have 2s or 3s or 4s. So, from the table of transform, we only have the single s. So, we must change the format into a single s. So, how to change to single s means that this 3s we need to divide by 3. So, everything have to divide by 3. So, now we can do it like this. So, 2 over 3, 3s over 3 minus 7 over 3. Okay, this 2 over 3 we can take it out because it's a constant. And then inverse Laplace transform. Now we left, this one can cancel out, we left s minus 7 over 3. Okay, from here we know that again from the exponent 80 equal to 1 over s minus a. From this one we change it to, your a is 7 over 3. So exponent 7 over 3 t. Okay, another example like inverse Laplace transform of 1 over s squared plus 64. Okay, if you look at this question, it's an inverse transform of 1 over s squared plus 64. So 64, the square root of 64, you will obtain 8. So this one, we can write in this way, s squared plus 8 squared. Okay, now let's check the table of Laplace transform. If you have the sine 80 is equivalent to a over s squared plus a squared. If you have a cos 80, you may get s over s squared plus a squared. Okay, now let's compare. Let's compare this one with the table of transform here. Which one is nearly the same? Okay, if you look at the denominator, s squared plus 8 squared. So nearly about, okay, there's a cos also can, sin also can. So now, if you use the sine 80, it should be a over s squared plus a squared. Okay, this one seems okay because a we can control our own. But if you use the cos 80, it is s over s squared plus a squared. Means that you need to divide by s. Okay, so it's less possible. So we use the sine 80. So how to change to a format of sine 80? So sine 80 we need a over s squared plus a squared. So now we know that our x here, our a here is 8. So we can 1 over 8 inverse transform of 8 s squared plus a squared. Okay, if you don't know why I need to 1 over divide by 8, Okay, if we cancel out this 8, I still obtain the same value as previous. But since we need to change it to a format of sin 80, we need the a here. So we substitute with the value of a, but we need to divide by 8 because we want to remain the value of 1 here. Okay, so we have 1 over 8 sin 80. Let's look at another example. Inverse transform of 8 over s squared minus 8. Okay, so first of all, we need to know what is the square root of 8. Okay, inverse transform square root of 8. If we didn't get a real number, we just write square root of 8. Okay. Equivalent to, so this case is same like previous case. If you have the s squared minus 8 here, we roughly know that it should be about sinh 80 or cos 80. So if you have the sinh 80, it is a over s squared minus a squared. If you have a cos 80, it is s over s squared minus a squared. Okay, if you compare with this one, we know that it is possible, most possibly is the sinh. So we can change to, this one is the square root of 8, so we take out the square root of 8 because we need the format of sinh 80. So inverse transform s squared minus square root of 8. So equivalent to square root of 8 sinh square root of 8 t. Okay. Now we go for another example again. Inverse Laplace transform of 1 over 8s squared plus 64. Okay, same like before, we have a single s only. So we need to either take out the factorize the s, or factorize the 8. So we change it to inverse Laplace transform 1 over, we take out the 8, we left the s squared, and then 64, okay, so you divide by 8, you have the 8 only. Okay, so what is this form? With plus, either is a sinh or cos. So usually we will take the sin 80. So sin 80 is equal to a over s squared plus a squared. Okay, we change the format. So we have 8 here. Again, we need, okay, we have 1 over 8 here. So we take out the 1 over 8. And then we want to change to the sin 80. So we need to follow the format like this. So inverse Laplace transform of square root of 8 over s squared plus square root of 8 power of 2. Okay, but we need to remain the value of this one. We need to remain the value. So we need to divide with 1 over square root of 8. So the answer will be 1 over 8 times with 1 over square root of 8 sin Okay, we go to another example. Hash is inverse Laplace transform of 4s over 4s squared plus 25. Okay, again, this 4s plus 25, we need to divide the 4s squared divided by 4 so that we get a single s squared. So we have an inverse transform of 4s over 4, and 4s squared over 4 again, plus 25 over 4. Okay, now this one we left s over s squared plus 5 over 2 squared. So if in this form we can change to cos at, because cos at we obtain s over s squared plus a squared. So we can change it to cos 5 over 2t. And last example I can give it to you can be inverse Laplace transform of 3 over 9s squared plus 4. Again, 9s squared plus 4, we need a single s, so we divide by 9. So equivalent 3 over 9 over 9s squared over 9 plus 4 over 9. So we can take out the 3 over 9 here. And then we left 1 over s squared plus, so we will want to square root it. You get 2 over 3. Okay. Okay, if this is the how we can change to this format? This one we can use the sin at a over s squared plus a squared. So this format, okay, we need the change to this format. So this one cancel out. We have 1 over 3 multiply with 1 over 3 over 2, which is the a value here, and then inverse. And then this one can cancel out, so we obtain 1 over 2 only, sine 2 over 3t. Okay, that's all for the inverse Laplace transform based on the table of Laplace transform. Thank you for watching.